Okay. So welcome to the course. I hope I am audible and my slides are visible. Okay. So this is the week 11 discussion. Okay, the second last class basically. So I am Udiptya, and today what we'll be discussing is the art of scientific communication. Yeah. So uh, we went through a lot of how to do research and what how was the philosophy behind research. So now the focus shifts to how, if we have done that research, how to make it available for the people to be to understand that, to communicate with them such that it is valuable for the people or the audience. Yeah. So for that, what will be this time what we will be seeing is we will go through some topics which are, first is scientific writing. Yeah. So scientific writing is an important part in which you have to write uh, some PhD thesis. That is anyway the last part of it, but of a PhD. But you have to write these reports periodically, also as some uh, progress reviews and all. Okay, so that's also scientific writing. So different text stylistics also you have learned. Yeah. So how to put different how to write. Yeah. What are the things that you should make, what are the formats, yeah, what is the style of it, what should be included in the body. Yeah. So those are the text stylistics. Then you have presentation and posters. So now this is basically a visual um, form of communication. Yeah. So you have to go for some seminars, conferences, and those are one of the other alternative form means of dissemination of research results. And by your presentations, how attractive it is, you would be able to understand, or you would be able to gain more uh, uh, views of other people, maybe gain collaborations, maybe gain some research connections that may be valuable in the long run. And like this discussion may also give you some new ideas. Yeah. So maybe you make something else, yeah, something new in your area of research. So the art of preparing a visual presentation is also is important. Yeah. How to prepare slides and all. Yeah. Then comes the writing grant proposals. Yeah. So yeah, we'll see. So PhD thesis, you have to have different chapters, which essentially will vary from 150 to 300 pages. And each chapter is something that will have an introduction and conclusion sections. And then you have a synopsis of the thesis, so which is around maybe 15 pages. In exam, how many MCQ will come? Yeah, I'm not aware how many will come. But it will be mostly, I don't know what's the full marks. That depends on it. And I'm not aware how much it is. Coming to scientific posters is something that should be digested in a rapid, concise, and a visual way. So, to make it easy to digest, you have to make it aesthetic, flowy, easy to read and understand within a few minutes. Not like you put the full paper on the scientific posters. Yeah. The typical poster has title, abstract, objective, methods, results, and discussion, conclusion, references, and acknowledgement. So this is not like the whole format, but it's kind of a free to change. But that's how a type typical poster will have. Okay. So we'll go to the questions. So for this session, I have included some questions from this part, and also then I have included some numericals because those are something that maybe because this section also had lesser theoretical questions, plus theoretical questions were kind of very general. So I thought you could practice more of numericals, or maybe we can discuss. Yeah. So yeah, that's it. Maybe some initial questions on this, and then we'll go for the numericals. Ideally, sentences in a thesis should be, yeah. So coming to the question, it's the first option, yeah. So your thesis, as it is a part of scientific writing, it should have a same family of fonts. Okay. Same font size is something that is not a must. Yeah. Passive voice is also wrong. So it should be plural first person. Yeah. And function names in italic is something. Function name, by function name we mean maybe sine, cos, right? Yeah. So that is also not required. So option A and D is the correct one. Ideal scientific poster should have the which of the following characteristics should have. Yeah. So uh, the first option, yeah, readable from at least 0.5 meters. So actually your it should be more than readable, it should be more readable for more than 1.5 meters. Okay. Text size should be above 20 points, should be a sans serif. So there are two kinds of fonts, yeah, sans serif and serif. So see, it should be sans serif. It should be same font family. Okay. So it shouldn't have the discussion pitch, yeah, it shouldn't have. Then graphs and figures should be always more than the running text. Okay. So this is an example research poster. Okay. So you have to tell what are the flaws here. So you can list it down as many flaws you want. Yeah, and tell whatever flaw it has. Okay. Okay. So yeah, too much. So it is text, yeah, then graphics. Okay, that's first point. Yeah, unnecessary figures. Okay. Okay. Then okay. Different fonts here. Okay, different fonts. Yeah, font style and different fonts. Okay. Yeah. Reference missing. Yeah, reference is also missing. Any other things that you all can notice? Yeah, unwanted, yeah, unnecessary figures I have written.
Hello.
Yeah.
Sir, the last one, what you read it?
Hmm? The reference is
Last one, that
missing.
unnecessary fonts, sorry, figures, then off fonts, then उसके बाद क्या लिखा है आपने?
Reference. We have the reference
Reference is
missing.
okay.
Okay. So another issue that I say is alignment. Yeah, we don't have a proper alignment. Background is dark. Actually, you can have dark background. Yeah, that is not an issue actually. But yeah, one thing is too many colors also is something. So yeah, maybe you will have some flaws in the text also. If you read it properly, there will be some text. Okay, reference basically. Okay, they have written literature cited. Okay, I didn't see it. Okay, yeah, but you will have something maybe inside also. Okay, in the text also. But yeah, just for showing you how a scientific poster shouldn't look is like this. Yeah. Okay. Typical research proposal format should have the following flow. So So, coming to the answer, it should be so the research proposal format. Yeah, it should start with the origin of the proposal. So, origin should be the first one. Coming to the review of the status of the R&D, then you go for the importance of the proposed project, then work plan, methodology, time schedule, plan of action for utilization of research outcome, environmental and ethical impact assessment. Yeah, expertise, the expertise of the researchers, expertise available with the investigators, summary or roles of responsibilities. Yeah, like that it will go. So basically it will follow this pattern. Yeah, origin, review the status and importance, because here you see, the work plan should always come before the methodology. It's not, the work plan shouldn't be late. Like the work plan is a list basically that you will be executing all these projects, and the methodology is something that will basically tell you the procedure on carrying out each work plan, like each step, each points in the work plan, how you plan to do the experiment or plan to execute it, that that and all you will be mentioning in the methodology. So work plan should always come before methodology. Okay, so now basically it will be mostly numericals. Yeah, I hope you all remember these numericals. Okay, okay, yeah, then you can solve it. The Z values for 90% is 1.62. For this one is 1.96, and this one is 2.58. So yeah, we'll start solving it a bit. Yeah. So first, what should we do is we can first calculate the new. Okay. So what we know is z. This formula we know. Yeah. X minus nu by standard error. Standard error we can find out by 3. Yeah. Standard error formula is sigma by root n. So 3 months divided by root 64.
Hold on. Hello?
Yeah.
Hello?
Yeah.
Sir, can you explain the one more time?
This
The
formula
formulas from?
standard
Yes.
error, you know.
For
Yeah. We have
standard deviation, no?
yeah, that is sigma is standard deviation
Hmm.
divided by number of observations. Yeah, number of items. It is 64. Yeah.
64. Okay.
Yeah.
Okay, sir.
So what we will get is we will, if in this formula if we put it the z, so it will be 60 sorry 20, okay, minus nu by 3 into 8. Okay, so if we bring the nu this side, so nu equal will be 20 plus minus, okay, so you have to have value of nu. Yeah, so yeah, z equal to 20 minus nu by, okay, so what we'll do is 3z is equal to 20 minus nu into 8, and then uh, what you have to do is 3 by 8 z, okay, is equal to 20 minus nu, and nu is equal to 20 minus 3 by 8 z. Yeah, okay, so it will be plus minus because z is plus minus. So so now we have to put the values, different values. Yeah, 1.62 in the place of z, and you will get the values for each confidence value. So for 1 I can solve you, so it will be 20 plus minus 3 by 8 into 1.62. Yeah, so you will get, I think one value will be 19.38 to 20.62. Okay, months. Other values, other second and third, you can solve and write in the chat box.
Hello.
Yeah.
So actually, in MCQ, if you take one question, previous question, multiple answers are correct, sir, like that. So if one answer wrong means what they will do, sir, in marks and all?
give in that assignment?
Assignment totally wrong. They are considered.
Maybe in the exam also it's like that.
Okay, okay, sir. Okay.
Okay. So I hope second and third you will solve, yeah? Anybody has got any answers? So just for I think second we'll have answer as 19.26 to 20.74, and third one will have 19.03 to 20.97 months. Okay. So you do it, just putting the value in it, putting the z in the in this equation. Okay, then we'll go ahead then. Yeah.
Hello.
Yeah.
So the first one answer is
19.38 to 20.62. Basically, you have to put the value of z in that equation. Yeah.
okay.
Mm. So like the last question, yeah, you maybe start with uh, calculating the uh, so most of the questions will have the same formula, z equal to x minus nu by standard error. So start by like getting those values, yeah, z value and all, standard error, how to calculate and all. So that may be the approach that you can take and see what the unknown is here. So what we get is, here it is written that x so x minus nu is plus minus 3, yeah, it is given here, okay, and z is also given 2.33, okay. Sigma is variance is given, so sigma we can calculate by root of the variance, yeah, which is 9. So standard error, basically same formula, standard error is sigma by root n. So 9 by root n value we don't know, yeah. So when we put all the values, yeah, in the equation, in the z equal to x minus nu by standard error equation, what we get is, we have 3 by 9 root n, yeah, equal to 2.33. So n is equal to 2 point so this will be 2.33 into 3 of whole square, yeah. So you have to calculate the value of n, yeah, here. So it is coming around 48.86. Okay, so we'll consider it as 49. Okay, so this will be the first part. What about the second one? How to do it? So when you have to have the precision to be doubled, what you have to do is this plus minus 3 difference from that mean, it should be halved. Okay, so what you will have to do is now z equal to x minus nu, same thing, yeah, standard error. Now the value of this x minus nu will be 1.5, yeah, because it was 3 before. Okay, 1.5, standard error will be same, 9 by root n. Okay, so what we'll have is I have to calculate the value of z, it will be same as 2.33. Okay, so same, I have to calculate the value of n, which will be equal to 2.33 into 1.5 by 9 whole square. Okay, so whatever will be the answer will be the number of sample that has to be taken for the precision to be doubled. So how much is it is coming? Sorry, I think I've written wrong here. 2.33 into 9 divided by 1.5. Okay. Yeah, it will be not. Yeah, so basically I think it is 6. So 2.33 into, so it will come around 14, yeah. So it will be 14 square is 196, around 196 I think. Yeah. So that much samples is needed for the precision to be doubled. Okay. Good enough? Should we go ahead? Okay. The mean plasma potassium level for 50 adult males with a certain disease was found to be 3.35 milliequivalent liter, and standard deviation was 0.5 milliequivalent liter. The normal adult value for a plasma potassium is 4.6 milliequivalent per liter. Based on the above data, can it be concluded that the males with disease have a lower plasma potassium levels than the normal males? So what we can see is the mean basically is 4.6 milli equivalent per liter. Okay. This is the population mean. Okay. And sample mean is also given. Sample mean is 3.35. Yeah. Standard deviation is also given, which is 0.5. And to find standard error, you can find it by 0.5 divided by 50, as 50 patients are there, yeah? 50 adults, so it will be 0.5 by 50, which is around 0.7. So now coming to calculating z. Z is x minus nu by standard error. So here we will put the two means, it is 3.35 minus 4.6 divided by point 0.07. Yeah, the answer will be 17.645. Okay, so it is, so you have to calculate it from the z value, z table. Yeah, z table says it is 2.58 and it is greater than 2.58, so you will so whatever the null hypothesis will have that the males with disease do not have lower plasma levels will be rejected. So H naught will be, males will have, males with disease, yeah, lower plasma do not have low, lower plasma. And the alternate hypothesis with males with disease will have lower plasma. So basically null hypothesis here is rejected. Okay, H naught is rejected. Yes, Z value is already given. Okay, so we'll go to the next one then. So 17.645 is a calculated value. You are now, according to the test, you have to compare it to the table value. So depending whether it is greater than or less than the table value, you have to tell whether it passed the Z test. No, Z value is used here. Z value is Z value, so it is greater than the Z value. Z value is 2.58. It is greater than the Z value, so it is used. Yeah, that is the reference. So when we are doing the Z test, you have to have the Z value, otherwise how will you do Z test? Understood? Okay. So a total of 200 patients suffering from toothache were divided into uh, uh, two groups, 120 and 80. The first group received drug A and the second group received drug B. The efficacy was measured by reduction in pain after the drug intake. Drug A failed in 36 cases and drug B in 16 cases. What is the standard error P1 minus P2 between the failure rates, and what inference will be drawn here? So you can take here the test 95%, which is 1.96. Okay. So here basically this means that whether these two groups are connected or not. Okay. Whether these two here we have two groups, yeah, 120 and 80. Whether the failure rates, yeah, the toothache rates, yeah, the failure rates of the drugs are different, yeah, difference is there or not. So that's the
Sir, audible?
Yeah, tell.
Okay. No, sir. Just I checked. Thank you.
No, I gave this question to solve. Yeah, I'm not speaking anything. Okay, so first what will we do is we will find P1, yeah, the probability of group P1. So P1 will be 36 divided by 120, which is around 0.3, and P2, which is 16 by 80, which is 1 by 5, or 0.2. Yeah. So here comes the standard error, which formula is given. It will be 0.3, 1 minus 0.3. So if you remember this formula, yeah, we have used this formula actually, 120 in the previous questions, yeah, when we were discussing this section. Root P bracket 1 minus P by N. Divided by 80. So it will come around 0.061. Okay. So coming to Z, it will be P1 minus P2 by standard error. So it will be 0.3 minus 0.2 divided by standard error, which is 0.061. So what we get is 1.639. Okay. Now what you have to do is, it is less than the table value, yeah, 1.96. So what we can do is, we can accept null hypothesis. Null hypothesis accepted. Yeah, there is no difference in P1 and P2, yeah, failure rates, or the failure rates of both groups are same. There's no difference, yeah. That we can say with 95% probability. We have taken 95% as our matrix. 95% confidence we can say that P1 and P2 failure rates are not different. There's no difference in failure rates.
Sir, actually, one doubt is there, sir.
Mm.
So, see here, you have inserted that P1 minus P2 in that question. You have done P1 plus P2 here, which means you have summed up both the square root.
Hmm? What?
Actually, square root of P into 1 minus P by N, right? That formula we have used here, right?
Yeah.
So we have to sum up both the errors, sir, P1 and P2 here for standard error.
Yes.
Okay. Thank you.
Okay. Any other doubts? Okay. So yeah, let's solve for